Hi, this is Paul from Netskope speaking, and in this video, I would like to showcase a few different capabilities of the Netskope cloud security platform. So Netskope is a security services edge platform which offers customers the capability of implementing secure web gateway controls, data loss prevention, threat protection, zero trust network access if users are roaming access into private applications, and much more. In this specific video, I'll be focusing on some of the next generation secure web gateway capabilities and really more of what the user experience is on what Netskope can deliver to our customers. So let me quickly set up this demo and explain what's happening. First of all, at this point in time, think of this machine as a machine and a user that's working remotely from home. The user's machine is managed and there is a Netskope client installed, and this client is then tied to the organization's tenant. So a tenant is unique for every organization, and it points to obviously the multi-tenancy that lives or exists in the Netskope cloud. The client connects to the cloud in a secure manner using TLS 1.3, in this specific case UDP-based TLS, which means that we can optimize the connection and make the performance faster by steering via that tunnel. And what we're going to do is I'm going to show you that essentially the first thing that the client allows us to do is to steer traffic via Netskope. Now bear in mind, the client is not the only steering method. It's one of our many steering methods. We can steer with IPsec tunnels, GRE tunnels, explicit cloud proxy, there's some virtual appliance options, or even proxy forwarding options. But I am using the Netskope client in this demo because of the convenience that it offers, as well as some of the other capabilities like showing users pop-up notifications on the desktop and so on. So first of all, what I can show here is that I am currently browsing the internet via the Johannesburg point of presence, which is the closest point of presence to where I'm located. If I disable this Netskope client, which by the way is something that you can restrict in policy, and generally you would restrict in policy, you wouldn't allow users to disable the client unless they are required to be able to do so as part of their job function. So here you can see I've disabled the client and I'm now no longer steering traffic via the Netskope cloud. And at the same time, if I re-enable it, we should see that traffic being steered again via the Netskope cloud in a moment or so. Okay, so refreshing that page shows us that we are now steering via the Johannesburg tunnel again, and we understand that the traffic's flowing via that secure services edge platform. The first thing that I want to showcase is just a simple control, and that is a baseline for pretty much everything else. We know that the cloud is encrypted today. More than 80% of cloud traffic is encrypted. And the reality is, if we wanted to be able to enforce policy and control of both cloud applications, as well as prevent data loss or even detect malicious files or malware inside data transactions, we would have to be able to decrypt. So the first thing fundamentally that the Netskope cloud platform does is it enforces SSL or TLS decryption. Now, what I'm showing you here is I'm doing a basic search for car on Google, but you'll also see that safe search is being enforced. And at the same time, this is possible because we are decrypting and re-signing the traffic with a proxy decryption certificate or signing certificate. Now, one of the conveniences of the Netskope client is that it takes care of the certificate chain of trust. So when we install the client, it also installs this decryption certificate, which allows us to avoid any SSL decryption errors on users' devices. So that's the first thing, right? And this is one of the big benefits of using as a service platform for security, in that when we enable decryption, the problem of dealing with the performance impact is no longer a hardware problem on site, but it's something that is being done by the cloud and the vendor offering the service. Right, so that's the first thing, and it's really the baseline of everything else. Now, once we've done decryption, obviously the benefit of doing that is it also allows us to detect data and movement inside encrypted traffic. So one of the things that we can do is we can detect obvious malicious files like, iCar. iCar is a test malware, and essentially if we try and download that via a secure web server, we will decrypt it, unzip the data, look inside, and we'll detect that this is a malicious file that's being downloaded. This is not just a URL filter, but it's actually the file itself. Now, just to prove that in a little bit more detail, if I open my OneDrive, now bear in mind this is my personal OneDrive instance, and I go into the lock here again, you can see this is being decrypted, and I try and download a potentially malicious Word document. That Word document will be downloaded, the traffic will be decrypted, and we will have a policy that scans and enforces the policy there. So let me just do that again, download. And what we'll notice is as soon as this file is being downloaded, or trying to download it, we see that there's a pop-up notification that comes up, and it tells us that there's a malicious file that was detected, essentially allowing us to do detection of malicious data regardless of what the application is, right? Even collaboration and cloud apps. So that's the first thing. Other capabilities that we have in preventing threats include the capability of not only alerting users of browser-based activities, but because the client intercepts and steers traffic at a kernel level, we are able to detect maybe second stage downloads, right? So maybe there is a malicious document that has a PowerShell script that tries to download a second stage payload, like a netcat or something else. We can detect that and alert the user that this is happening. And this same behavior can also be used towards data loss prevention. So for instance, you have a developer using AWS command line tools. They might by accident be synchronizing PCI DSS data to a development database inside the Amazon cloud. We can detect that sync and notify the developer that they are by accidentally potentially exposing data that should not be exposed. So that's some of the other capabilities that we have there. Now, getting back to the Secure Web Gateway, one of the more modern approaches to dealing with unknown cloud content is to isolate. Netskope has a browser isolation capability. I'm going to visit CNET. This is just a demo of how we can enforce browser isolation, but generally speaking, browser isolation would be applied to a unknown or newly registered type of domain, with the purpose of allowing users to access that content. But because we don't know if it's good or bad yet, we then redirect the user's request into a cloud-based sandbox where the Netskope cloud renders the content and then serves it to the user inside a pixel stream. Essentially, the user is able to interact with this page. They can click on files, they can view media. You'll see in a short time media is loading. So the site looks completely functional. However, if they try and perform any data exchange, that would be blocked, right? So they wouldn't be able to download anything. They wouldn't be able to copy and paste clipboards, because essentially the browser that's running on the client's device is completely isolated from the website, and any active script will not be able to exploit the vulnerability into the browser's website. So a very effective way of protecting users from potentially malicious sites, but still allow them to be productive and give them access into the content. Right, so that's some of the threat protection and baseline secure web gateway features